We're going on now to topic 4 of chapter 3, which I believe is a relatively easy lesson. So let's get started. These are the objectives, and pause if you want to read them, otherwise we'll go on. So adding and subtracting polynomials. First of all, we're going to build some background in vocabulary, classifying polynomials. So our first term is a monomial. Now, what are monomial terms? Well, as we look at these examples here, there's 1, 2, 3. Notice by a term is separated by either a plus or a minus. Here, and the commas, of course, separate the terms in this case. There's 5x, that's a term. Negative 7y to the second, that's a term. Now there's one negative sign, but that's in the front. Oh, then we have a 4 all by itself, so I missed that. Then we have 1/8 x squared y squared. So there are 4 terms here, but separated as a comma, they're considered monomial. Mono is the prefix for 1. Now, one of the questions they're going to ask you as we move along in this is something a true polynomial? And they give you some hints here. Now, this is not a polynomial or a monomial because it has a variable in the denominator. This is not a polynomial or subclass monomial because it has a negative exponent. And this is not a monomial or a polynomial because it has a fractional exponent. So these are 3 things you need to be aware of. You want to write them up separately, you can, but no variables in the denominator, no negative exponents, and no fractional exponents. If they have these, they're not considered polynomials. And the subcategory here is a monomial. Now, as we continue our vocabulary here, you might say, how many terms are here? Well, 1, 2, 3, 4. Now we think of a degree of a monomial or of a term as the exponent on the variable, and it's actually the sum of the exponents on the variables. So let's figure out the degree of each of these terms. And we want to mention that here is sort of a standard form for the monomial, where the k, that is the number part, is the coefficient. We've had that before. So the degree of this term, and it's only on the variable, is the sum of the exponents, which is a 2. The degree of this term, and there's a 1 that we don't write, would be the sum of the exponents, 3. Now the degree of this term, and there's only the 1 exponent, is 5. Now when you have a constant like this and there's no variable, we say the degree is 0. So these would be the degrees of the monomial single terms. But since this is an expression, if it was only 2 terms, it would be a binomial. We're getting to that shortly. If it was 3 terms, it would be a trinomial. And if it was 4 terms, we don't have a special name for it. We just consider it a polynomial. Now, the numerical part, along with its sign, is the coefficient. And if you just had an x or a negative x, the coefficient would be 1 that we wouldn't write. But here it would be a positive 1. Here would be a negative 1. All right, so some background. One other comment before we go on as background. If this were an expression and they asked you what was the degree of the expression, and note this carefully because many students make errors, it's the degree of the highest term. So that would be 5. Now you wouldn't add up all the different terms. It's just the degree of the highest single term is the degree of the expression. All right, let's get back to our lesson as we move along. Here are the formal definitions now as we look at these of a polynomial. A polynomial is a monomial or an indicated sum and or difference of monomials. The degree of a polynomial is the largest of the degrees of its terms after like terms have been combined. And here's another one. The coefficient of the terms of the largest degree is called the leading coefficient. So if you had something like this, 3x squared plus 5x to the fourth minus 2x. Now, even though the 5x to the fourth is not in the furthest to the left, because its degree is the highest, this would be the leading term, and this would be the leading coefficient. So it's not just the one that happens to be in the beginning, because this should be put normally in ascending order. All right, let's go on. Now, as we build background, we're trying to get everyone to be familiar with the vocabulary that we're using. So once again, they're reviewing what we said earlier. Monomial is one term to the third degree, and our coefficient is 15. Binomial, bi, is two terms, and here this is 0, this is 1, so our degree is 1. Here's a trinomial. Now we have a 3-term polynomial, and the degree of this is 4. This is 1, and this is 0. But the degree now of this expression is only 4. It's only when you have something like this, 2x squared y to the third, that you add your exponents and you get a 5, and the degree of this term would be 5. When they're in separate terms, it's only the highest degree of any single term is the degree of the expression. Now, I know we're repeating, but we're doing it purposefully. Again, building vocabulary, and the degree of 0 or 1 is called a linear polynomial. Now, we mentioned that in the last section. Linear, it's the exponent is only to the first power, or it's a 0 power. If it's to the second degree, it's called a quadratic, and that's where we're moving to study quadratics. And then degree 3 is called a cubic polynomial. Sounds like good quiz questions here. So, some examples. This is a binomial, and it's linear. This is a trinomial, and because of the second power, it's quadratic. This is a monomial, and because of the third power, it's cubic polynomial. Now, the leading coefficient of this is not 10, but negative 10. If it's positive, you don't have to include the sign. But if it's negative, you must include the sign. So we spent, again, almost 10 minutes on background information. Now we're finally getting to an example. And generally, you could do things horizontally, but I like the concept of vertical. So if you're going to add two items here, you could take away the parentheses because it's plus, and this would be x to the third. You're going to skip a spot, put negative 2x, and then 1x. Now, you could, in a sense, you could put a 0x squared there that has no value as a placeholder. Then underneath it, you're going to line up your like terms. So this would be 3x squared plus 4x plus 5. Now, you're just going to add them up. And keep in mind, when there's no coefficient, there's a 1 there. And for calculations, you can put it. So this would be a 1x cubed. This would be a plus 3x squared. Now here we're doing subtraction or adding unlike signs. This is a plus 2x plus 6. Now if in MATLAB you put the 1 there, they're going to take off for that. For calculations, you can put the 1 there, but don't write it. Now, this is done, again, exactly the same way. I'm not going to illustrate it because it's pretty straightforward. Now, for the second example, again, you might say, should I write them down if we don't go over them? Well, if we don't go over them, you don't have to write them down. But if we do go over this, as we're going over it, putting it in vertical columns, I do want you to write this down. I'm not going to write it because it's there. And notice they've used a placeholder just to keep the terms in like term columns. This is what we feature. And it never hurts to go back and check your work. Be sure you copied it correctly and you have the signs correct. Now, number 3 we'll do together. So write example 3. And again, this is subtraction. Now, the thing about subtraction, you might say, how do I know it's subtraction? Well, because of the subtraction sign between the two parentheses. Now, my suggestion, again, is always do these vertically. So you're going to get 1x squared y, that's this term, plus 3y minus 4x. So for this one, I just took the parentheses away, and I've written it as it is, and I've put the 1 in there to help me with the calculations. Now, this is the critical part. When you see a negative before the parenthesis, you could think of that as a negative 1 there, that you're going to multiply each term within the parenthesis. And what does that do? That changes the sign. So the shortcut of this would be, if there's a negative in front of a parenthesis, you remove the parenthesis and change each of the signs of the terms inside. So this one, where it's a positive initially, will now become a negative 2x squared y. And you line up your like term columns. Now, this is a negative 7x. So you're going to make this a positive 7x in the right, correct, like term column. Now you could put a 0 here if you want, or leave it blank. So now you've set it up properly. You've converted the subtraction by changing each of these signs and then adding. So this becomes a negative. We could put a 1 there, but we don't. X squared y. Just bring this down, plus 3y. Now do this subtraction and you end up with a positive 7x, which is what they have. Okay. For number 4, I'm not going to write it out, but I do want you to include it in your notes. So here's the example. Well, I'll write it out. So x squared, put a 1 in front, plus 12x minus 23. Now I see a negative sign in front, so I'm going to change each of these signs as I write them. So this is going to be a negative 2x squared. This is going to be a negative 7x, and this is going to be a positive 20. Draw my line, and then again, this is a negative x squared. This becomes a positive 5x, and this becomes a negative 3. So the key is, when you have something like this, I strongly advise you put it up vertically. Negative, remove the parentheses, change each of the signs, like term columns, add them up, there's your answer. Okay, we're only going to do A because B is just a repetition, and you'll have your practice. Now, in this next part, we're going to take a look at what is called function notation, and then evaluating polynomials. And we've commented on how to write function notation. They usually use a lowercase letter, but again, and I will go over the significance of that as we move on. Now, for example 5, I'm going to go to the whiteboard shortly, but I'd like you to write this part down. And it's this expression right here. So P of x is such that x cubed minus 2x squared plus 3x plus 5. Find when P is of 4. Now we want a strategy for doing that. And here's the strategy as you do part A of number 5. So whenever they give you a value like this, what they want you to do is take that 4, and wherever there's an x, you're going to put the 4 there. And I would suggest you put it in parentheses. Now the x is going to be 4, and this x is going to be 4, and this is going to be a 5. Okay, so what have you done? Well, we're looking at function notation, and then we're substituting the value they want into the expression. You need to be careful of the signs. This is a positive 4, but put it in parentheses like this. So now we get 4 to the third, which is 64, minus, this is the minus. Now 4 squared is 16. 2 times 16 is 32. This is straightforward. 4 times 3 is 12, plus 5. And you get your results. Now when we add these all up, you're going to see down below here that it ends up being 49. And let's check that. So I took out my trusty calculator and I added 64, 12, and 5, got 81, and then subtracted 32 from it and got 49. All right, we'll do one more. Now as we set this up, and we'll go to whiteboard here, You want a protocol. So I would go like 2, and then I'm going to have a parenthesis, squared. Then I'm going to have a parenthesis there, minus parenthesis, parenthesis, we're doing this one, plus 3, parenthesis, minus 4, parenthesis, plus 15. Now I'll change colors, and wherever there's an x, we're going to put in a -1. So there's an x. This will be -1. Y is -6. X is -1. See, here you might say, well, there's a negative already, but no, in parentheses. Got to do that. Y is -6. X is -1. Y is -6. So we'll pause and we'll see what we get here. All right, this took some time, but worth the effort because it's one of our most challenging here. So here's a little tricky. -1 squared became a +1. So +1 times a -6 is a -6 that you're later going to times by 2. Now here, negative times negative made this a +6, but the negative is still there. Now -1 times 3 is a -3. -4 times a -6 is a +24, and we have a 15. So I did this multiplication, got a -12. This is a -6, -3, added these 3 up, got a -21. Added these 2, and I got a 39. Subtracted 21 from it, and I get an 18. So quite tedious to do this one. And as we look at what's shown here, and I'll take that off so you can see it a little better, it comes out as an 18. Okay, now they do show the breakdown of this. And this will wind up lesson 4.